Now students, welcome back, and in this video we will learn about the graphical representation of data, or moreover showing data in a pictorial form, in a picture form, which is even a better way of showing of data and organizing it so that we can get more information in less time, and just by a glance we can get major information of the data. So now let us see what all is in the graphical representation. Now in your course, we'll study about three types of graphical representation. There are many more types like pie chart or a linear graph. But now in this chapter or in your course, we learn about these three types. Now the first is bar graph, second is histograph, and third is frequency polygon. Now, let me just read out this information that is given to you about the graphical representation of data. Now, usually comparisons among the individual items are best shown by the means of graphs. The representation then become easier to understand the actual data. Now, just as I have told you that graphical representation or the representation representation helps us to get more of an idea of the data by looking just at it, by just having a glance at it, and it is showing our data in a more representative way, and it makes us our lives easier to get to extract the information out of the data. Now let us see how do we make these types of graphical representation, that is the bar graph, histographs, and the frequency polygons. Now, let us move on to bar graphs. Now, bar, you might have known what bar would mean. Bar is anything like rectangle and having some height or width and length. Now, for example, a chocolate bar, right? So you eat a chocolate bar, and that chocolate piece is called a bar because it has a kind of a rectangular pillar-like shape, right? So now this is a bar. So similarly, in a bar graph, we represent the data by using bars. Now, a bar graph is a pictorial representation of data, in which usually bars of uniform width are drawn with equal spacing between them on one axis, and that one axis we take as our x-axis, and depicting the variable on the y-axis. Now the variable here means our frequency. Alright, so we depict our frequency on the y-axis, and our information of which the frequency is given, we depict it at the x-axis. Now the values of variables are shown on the other axis, that is y-axis, as I have already told you, and the heights of bar graph depend on the values of variable. Alright, so we have these bars of equal width with equal spacing between them, and the height shows the value or the frequency of the variable. Now let us move on to a question so that you can best understand bar graph. But before moving on, I'll just give you a small insight that histograms, you might find histographs, if you would have already read about them, then you might be confused about the difference between bar graph and histograph. Well, there is a difference, and about that I'll tell you more in when we go on to our topic of histographs. So first, let us just get familiar with our bar graphs. Now let us go to our example number 5. So in this question, we are given that students were asked about in class 9, 40 students were asked about their months of their births. Now they were asked for in which month they were born, and the following graph was prepared by the data observed. Now this is the graph that we have prepared by the data. Now you see that we have written months over here like Jan, Feb, March, all the 12 months are here, and number of students are depicted in the y-axis. This is our y-axis, this is our x-axis, and number of students is nothing else than frequency. So now our first question is, how many students were born in the month of November? Now we have to extract the information from the graph given. Now how many students were born in the month of November? Now to do that, first of all, let us go to November. This is our November. Now we'll just draw a straight line from here. let us draw a straight line. Now this is not straight, but you get the idea. Now if we'll draw it, I'll just try to make it more straight. Now if we'll draw a straight line, you'll see that it is intersecting with 4. You'll be drawing the graphs on a graph paper. So there you'll get the idea, and you'll not need to be drawing these lines by yourself, because graph paper already have these lines. So you'll easily be able to know what value does November has. So now as we drew the straight line, and it is intersecting at 4. So now that means that the number of students that were born in the month of November is 4. So we just write here 4. And now in which month were the maximum number of students born? Now to find the maximum, just look, just as I have told you, that frequency is proportional to height. That means higher the height, higher would be the frequency. That is, the maximum number would be of the tallest bar over here, which is August. So that means that the month in which the maximum number of students were born is August. And now similarly, if we were to ask about the minimum number about the month in which the minimum number of students were born, minimum number of students. If we were asked this, then now we'll look at the bar with this shortest of height, and which is June. So our answer would be June, where only 1 student is born, right? And while in August, if we'll see that 6 students are born in August, right? So let us move on to our next question. Now in this question, in previous question, we were given a plotted bar graph. Now we will learn how to plot the bar graph. Now in this question, it is given that a family with a monthly income of 20,000 has planned the following expenditure per month under the various heads. Now this is now the total price that we have is 20,000, and now the family has planned to spend the money like this. Now this is not just 4, it is 4,000 rupees as it is written over here. So now we have the frequency over here. We have our contents over here, that is what we have to plot on x-axis, and this will go on y-axis. So if we'll draw our x, our y over here, and our x is over here, then first of all we have to write or measure the grocery, that is, now first of all we have to measure the grocery, that is, how much is it? So it is 4. Now before drawing this 4, first of all let us mark the markings over here. Now you see the highest number is 5, so we have highest as 5, and the lowest limit is 1. So we will start from 5. So we will start from 1 and we will go on to 5 and even higher. So we have 1, 2, 3, 4, 5, and we have interval as 1, because you can see that these can be shown with interval of 1, and then we may draw 6 and 7. Now what we'll do next is we'll mark these names. We mark these content over here. So we'll have a place for grocery, then we'll have another, we'll leave the gap, and then we have another for rent, equally spaced, then we have another for education of children, medicine, and etc, etc. So now let us see in a more clear way how it is drawn. Now this is what we have drawn till now. Now these are our heads, which is given at x-axis, and this is our frequency, that is the expenditure, that is in 1,000 rupees. Now here we have 1 1 1 1. The gaps is in 1 1 is 1, and it is ranging from 0 to 7. So but our even though our height, our maximum figure is still 5 and lowest is 1. Now what we'll do is, now let us start marking these things. So first of all we'll mark grocery. So grocery is at 4. So what we'll do is we'll mark till 4. Now let us draw the graph at 4. Now next is our rent. So we have our rent at 5. Now We'll leave space equally, we'll leave the space over here, and then we'll draw our rent, which will be at 5. If it is a straight line, then it's stacked over here, and then we'll mark it even here as rent. Now next, let us move on to education of children. It is again 5, so we'll have again 5. Now you see that there is equal space left over here, and now we'll mark as education of children. Then next we have medicine at 2. Then we have fuel again at 2, so we'll leave the space. Then we'll draw here. And then we have entertainment at 1. So our 1 is over here, so we leave another space. First of all, it is do with fuel. So we'll leave another space over here. Leave some space, and then we have entertainment at 1. So we have it till here. And then we have another point, that is miscellaneous, that is anything, it may be as backup budget that is left, so we have it at 1 set. So now you see that we have equally spaced bars standing and representing the data, right? So this is how we plot our bar graph, and we have written all the names of heads over here. That is where we are spending our money, and then we have represented our frequency over here. So this is how we are going to make a bar graph. Now let us move on to a histogram. Now you can see that histogram looks similar to bar graph, but let me just read what histogram means. Histogram is a graphical representation of a grouped frequency distribution with continuous classes where there are no gaps between the consecutive rectangles. Now in this definition itself, we get the difference between bar graph and a histogram. Now first is it is a graphical representation, while the bar graph was a pictorial representation. But mostly what is most important is that it shows the grouped frequency distribution. That means you can see here that here we have had continuous distribution. So if we have to represent something in a range like 20 to 29, then we have 30 to 39, 40 to 49. Now if we have to represent something in this range, if we are given a range and then we have given a frequency, then we have to use histogram. While if we are giving names, if we are given names like basketball, how many people play basketball, and we are given 4 people, then if we are not given these continuous intervals, rather we are giving discrete names like basketball, and we have football, how many people play football, it is 3, then we show them by bar graph. We can show them by bar graph. And if we are given numbers like 20, 30, 40, then since these are not continuous intervals like these, so these can also be represented as bar graph. While if we are given a continuous interval, that is a grouped frequency distribution with continuous classes, then we represent them by histogram because it have no space between them. So we can continuously make the interval like 30 to 35, 30 or 30.5 is going straight up to 35. So now you can see that this is one interval. I'll just mark the intervals as if, which you can see. So this is our first interval, then this is our second interval, then we have our third interval. So you see that we have our intervals over here. So one width of a histograph is given by its interval. Now let us see the histograph. Now in histogram, the areas of the rectangles erected are proportional to corresponding frequencies. Now this complete area is proportional, but while in bar graph only the length, that is the height of bar, it was proportional. But in histograph complete area is proportional, where width is given by the class interval. But if our width is are all equal, that is our class intervals, are equal, that is our class intervals are equally spaced, then only the length would be proportional to the frequency. Then we can easily represent them by their lengths. So the another difference that we have learned about bar graph and histogram is that in histogram only the length is proportional, while in bar graph only the length is proportional, while in histogram complete area is proportional. But if we are having our width to be same, that is our class intervals are all equal, then only the length would be proportional, just as a bar graph. Now let us do a problem to make you understand the concept more clearly. So here we see that we have our first interval as 0 to 20. Now if I draw here a class size or class interval, or maybe we can call it as our width of histogram. Now if we draw make the class size, now class size is given by upper limit minus lower limit. So we see that this it has a size of 20, while here we have 10, here we have 10, then we have 40 to 50, which is 10, then we have 50 to 60, which is 10, and then we have 60 to 70, which is 10, and then we have 70 to above. Above here means 100, as it is given in question. So we have 30. Now let me just read out the question so that you can now I've just marked in the class size and nothing else related to the question. So let me just read out the question so that you get the idea of what this table actually represents. So now here the teacher want to analyze the performance of two section of students in a mathematical test. Now the teacher is analyzing the performance of the students in the mathematical test, and looking at their performance, she found that a few students have got marks under 20. Now these are our under 20 marks, and if you have got marks that are 70 marks or above. Now this is our 70 marks or above, and I have said that 70 to 100 because we see that our above are our maximum marks that is possible is 100. So above will reach the point of 100. So looking at the performance, she has found these information. Now she has decided to group them into intervals of varying sizes. Now the size of these intervals vary, as we have just found out by analyzing their class size. And she has formed a table, and now we have to draw a histogram for the following table. Now we have varying width. So so our width will be proportional to our class size, and we'll make it accordingly. So that means that our width of 70 to above would be 3 times, because it is 30, so it will be 3 times of the width of our intervals, like this. So that means if we are representing our interval 30 to 40 to be like this, then our 70 to above will be represented like this. That is 3 times of the width of the previous of the class interval of 10, because 10 is the least class size of the given intervals. So now we'll mark the histographs over here. Now we have marked things. First we have drawn the class intervals. Now we draw the class intervals. That is, we mark the marking over here by choosing first of all the lowest. That is, first let me just make another column over here with class size. So our class size is 20, 10, 10, 10, 10, 10, 10, then we have another 10, then another 10, and then 30. So we choose our lowest interval, lowest class size, we choose our lowest class size, and then we divide the points, that is, we divide from lowest to highest. So here lowest is 0, so we have to make it directly from 0, 0 to 10, 20, 30, and our highest is 100, so we have made it 100. You may include 110 and all, but that will be left blank. So now, since we have made it like this, now what we'll do is, now we'll go on to represent things. Now we have 0 to 20, it is given as 7 students. So first let us just make these graph, and there will be a problem over here, but let me first make the graph. Now first our 7 would come over here, So we'll make our graph like this. And it is 0 to 20. Then we have our another graph between 20 to 30. So now we have 10 students. So we'll make over here, right? Then we have our another 10. So it will be directly joining. Then we have 40 to 50. So we have 40 to 50, 20. So we'll reach over here. Yeah, it's here. And then we have 50 to 60, that is 20, another here. Then we have 15, so we have 15 over here. So now we will draw our interval 70 to 100. That is drawn like this. So this is our 8. But now, do you see a problem over here? And that is that we have drawn our interval, that we have different interval, and we have taken the frequencies as it is. That is 8 for all 30 students in between. But this will lead to our area to be very large, right? Because histogram is not just proportional to the height. That is, histogram is proportional to area and not just to height. So our height remains as it is given, but our width is very large. So our area would increase a lot, and it will not give us the correct representation of what our data actually looks like. So so we need to modify our histogram in this sense. So now let us see how do we do that. As the areas of rectangles are proportional to the frequency in a histogram. So as I've already told you that histogram is proportional to the area and not just the height, right? So it is not just the height that will affect the histogram, it is the complete area. So in the previous example, as the width of rectangles are varying, it does not give the correct picture because the area would be large enough. It will be much larger than the actual value it should be. So we need to make certain modification in the lengths of the rectangle, and to do so, we'll have these we'll follow these steps. Now the rectangles in now the modification are to be made so that the areas are again proportional to the frequency. Okay, so let us see how it is to be done. So first of all, we will select a class interval, and that class interval should be of minimum class size, right? So in our previous question, as it is, so our minimum class size is 10, right? Because as you can see here, we have 20, 10, 10, 10, 10 and 30. So our minimum class size is 10. So we'll take a class, we'll select a class interval with minimum class size. So we have our 10. Now the length of the rectangle are then modified to be proportional to the minimum class size. Now we have to make them proportional to the minimum height size. And now to do that, let us see what is to be done. Now you see here we have the same question, and we have written our mass, frequency, class size. Now length of rectangles. To do that, first of all, you can see that it is twice the height of the width of the minimum class size. Now to make it to be equal to minimum height class size, what we'll do is 20 by 2, and same thing we'll do it frequency. So we'll divide the frequency by half. So we have 7 divided by 2 and we get 3.5. Now similarly here, to make it to be equal to class size, we have to do 30 by 2. So now 30 by 3, sorry. So we have 30 by 3, and since we get our number 3 to be 3, so we'll do the same thing with the frequency. We'll divide 8 by 3 and we'll get 2.67. And the frequency of these interval will remain as it is, because 10 divided by 1 is 10 only. So we just have our 10, 10, 20, 20 and 15. And now we will plot these values as our frequency for the histographs. So as we draw this, we have got our length of the rectangle. As we see, our length is nothing but it will act as the frequency. So now proportional. Now we have written here marks, and we'll start doing it. We have 10, 20, then we have 40, then we have 50. For 40 to 50, we have, you can see, we have 20. Then we have drawn our histograph for 50 to 60. 50 to 60, it is again 20. Then we have drawn for our 70. Now it is again we have marking 15, and now for 70 to above 70 to 100 we'll have 2.67, so it will come over somewhere like here, so we'll mark it here like this. So that is how you mark the histographs, and you can see in the first interval also from 0 to 20 we have 3.5, so our 3.5 will come over here, our 3 would be here, and our 3.5 would be somewhere here. So now we have marked the point and we have drawn the histographs. Now let us study about frequency polygon. Now if we join, frequency polygon is nothing but a modified version of kind of this of representing the data. Now if we join the midpoints of the upper side of the adjacent rectangles of an histogram by means of line segment, then the figure obtained is called a frequency polygon. Now, what does this mean? Now, this means that whenever we are given a data and we have drawn a histograph, now to get the frequency polygon, all we have to do is we have to join the midpoint. That is, its midpoint, the bar's midpoints, and we'll join it by using a data. We mark it as B. Now we have joined it by using a line segment. Now similarly here also we'll join like this, and we'll mark here also center, center. We'll join like this and like this. So it will curved over here. So I'll just draw it again. So we have like this. Now you see that we have kind of sort of line, different line segment joining up. And now let us just see how it in a more clearer picture. So what we'll do is mark the we have marked the midpoints as I have done right now, and then just join the line segment as we are joining B to C, C to D. All the midpoints are to be joined with the adjacent rectangle. So now here. Now this is how we join it. Now let us see how to make a polygon out of it. Since it is written polygon, and it is called frequency polygon because first of all it will make a polygon over here, and second of all it is showing the frequency, right? So it is marking the frequency of the given data. So now if I'll draw it over here, you see that it is in air right now, right? This is our B, this is our C, D, this is our E, and F is going even below. And this is our F, and this is our G. Now you see it is in air only. Now to make a complete polygon, we have to join these points on the x-axis. Now to do that, let us see how to complete this polygon. To complete this polygon, we assume that there is a class interval with frequency 0 before the lowest class. So our lowest class was this, and now we'll assume that there is before this lowest class there was a class interval, and that class's frequency was 0. So we'll mark the center, and our frequency is 0, so we'll just mark it over here and we'll join the line. So to do that, see, we have made the point A over here, and then we'll mark another 0 frequency class interval, which will be just after the highest class. So our highest class was 55.5 to 60.5, and now we have to join. Now we'll take another class that is after that is 60.5 to 65.5, and we'll mark the center, then we'll join the line. Now this is our complete polygon. Now to what this enables us to do is that it makes the area under this polygon to be equal to the area of the histograph itself. The proof is not given in your course, so we'll just go on with the statement that the area under this polygon is equal to the area of the histogram, right? So by joining A and H with the x-axis, we have completed the polygon and we have made the area of these polygon. So by joining the x-axis with the and x-axis at H, we have completed the polygon. So by joining that x-axis by A and H, we have completed the whole polygon, and what we have ensured is that our area under the polygon, under the frequency polygon, is equal to area of the histogram as it is given over here. So our histogram's area is made equal to be our area of the frequency polygon. Now let us do some question to understand what how frequency polygon works. So in this question, we see, first of all, let me read out the question, that consider the marks out of 100 obtained by 51 students. So the total number of students are 51 of a class in a test. Now draw a frequency polygon corresponding to this frequency table. Now we have to draw a frequency polygon for this data given. So first of all, let us draw a histogram related to it. So we know our steps. First, histogram. Then we have to mark midpoints. Mark midpoints. Then intersect. Then join line segment. Join line segment. And then last step would be to intersect, to make the polygon, to complete the polygon. Complete the polygon by joining the line by intersecting with x-axis, and we intersect by x-axis by taking a lowest interval and a highest interval with frequency 0. Now here we have marked it. Now we see that our intervals are all equal. 0 to 10, class size is 10, 10, 10, 10. So all of these class sizes are 10. So we just mark it over here. And then we'll remember to take a frequency in class interval that is less or lower than the minimum class interval given, and higher than the minimum and higher than the maximum class interval given. So now here we'll mark the points. First of all, we have 0 to 10. So for 0 to 10, let us mark 5. So this is our, 5 would be here, right, after 4. So our 5 would be here. So we have first of all, it is basically draw a histogram. So let us draw the histogram. So 10 to 20, it's 10. So we are to draw the histograph over here. Then we have 20 to 30. So we'll have 4 over here. So we have it like this. Then we have 30 to 40, 6. We'll draw the 6. Then 7, 3, 2, right? And then we have another 2. Then we have 3 between 80 to 90, and then 90 to 100. We have 9. Now that we have got our histograms, now mark the points mark the midpoints of the histogram like this. We'll mark the midpoints and we'll name these points. Now let us name the points B, C, D, E, F, G, and etc. And to complete the polygon, mark the midpoint of the highest and the lowest. Now we have our lowest with 0 frequency like this, and the highest, and this will be named as A. Now we'll join the line segments. First A to B, then we go to B to C, then we go from C to D, then we have gone from here from D to E, then E to F, F to G, G to H, H to I, then I to J, then J to K, and at last K to L. And this is how we have completed our frequency polygon. And we have drawn our histogram, and then we have drawn our frequency polygon. Now, frequency polygon is not just dependent on histogram, but we can draw it independently itself. And that is by by marking the midpoint of the class interval. And since in histogram itself, we were doing was we were marking the midpoint of the class interval. So now these midpoints of the class interval are called as class marks. The midpoint that we have of a class interval is called class mark, and the Formula to find the class mark or the midpoint of the class interval is upper class limit plus lower class limit divided by 2. For example, if I take 20 to 29 as my class interval, then upper limit is 29 plus lower limit is 20 but divided by 2. So we have 49 divided by 2. Now this will be our class mark. If we'll divide it, we'll get 2 and we have 4.5. So this will be our class mark, that is midpoint of this interval. Now let us do the question. Now in a city, the weekly observation made in a study on cost of living index are given in the following table. Now we have been given about a table in which we are given the cost of living index. Now we have to draw a frequency polygon of the data that is given below. Now the cost of living index that is given is in interval 140 to 150. This is not just it is not rupees, but it is a kind of a marking or a scaling of what cost is to be done. So we are not concerned with what actually this would mean, because for this you have to study more of the economics side, but we are only concerned about the intervals that is given. So now here we see that the intervals are equally spaced. It is 10 10, difference in is in 10, and number of weeks as it is given is written over here. So now we'll have to draw a frequency polygon. Now to draw a frequency polygon, our first step is to find the class marks. So we'll first draw the table. We'll modifyly draw the table. So first of all, we'll write cost of living index itself. So let us do. So first of all, we have written cost of living index itself, but we have just added another column on class mark. And number of weeks is again the same. This is our frequency, right? So now class mark. To find the class mark, I have told you it is upper limit plus lower class limit divided by 2. So this is our class mark. Now in interval 140 to 150, our upper limit is 150 and lower limit is 140, and we have to divide by 2. When you do that, you get 145. Now I'll write 145. Now similarly in the second interval, we have 160 plus 150 divided by 2, and we'll get 155. So I'll just write 155. Now next is 160 plus 170 divided by 2. We'll get 165. Now similarly we'll carry on and we'll fill up this to be 175, 185, 195. Now these are our class marks, and the number of weeks is given to be this. Now we'll treat these as individual points, and we'll mark the frequency polygon. That is, at 145 we'll mark 5 as our points. Now now I'll just show you how it is done. So first of all, we have 145. Now you can see that we have taken it to be a discrete point and the center, and then we'll just we'll mark 145 at 5. So 5 is here, so we'll mark at 145 5. That is the frequency that is given. But before that, as I have told you that we always take a lower limit and a higher than the highest limit. Then so therefore the limit that will be lower than 145 would be 135, right? Because these are equally spaced, as you can see. So the lowest would be 135 and the higher would be 205, and we have 0 and 0. So first of all, it is marked at these points. So at 135 it is 0, at 125 it is 0. So we'll just mark it like this. Okay, so next step is at 155, it is given at 10. So we'll mark at 10 like this. Then we are given 165 and it is marked at 20. So we'll go on all the way up to 20 at 165. Now I'll just show you how it's done. So first of all, here you can see here it is marked A, and we have at 135 0, right? At 135 this point is called Then the next step we have our, at our 145 we get our 5, 145 5. You know how it is represented, right? It is x comma y. So our x is 145, our y is 5. So now next step is 155. It is given at 10, 155 10. Similarly, we move on to our point, next point, and we'll keep on naming them A, B, C, D. Then we have our point E, that is our 175 at 9, right? And then we have 185 at 6. Then we have our 195 at 2, and then our last 1025, 205 at 0. So now we have got all the points, and all that's left to do is to join them by line segment. So we'll join them by the line segment like this, and hence we have got our completed our frequency polygon. And this is how we make a frequency polygon. So now in this video you have learned how to make frequency polygon. You have known how to depict the data graphically or pictorially by using bar graph, histogram, and frequency polygon. And I've also told you the difference between a bar graph and a histogram. So meet you in the next video.